Did you know that AI models with billions of parameters are trained at scale? Would you like to see that in action? And moreover, would you like to ask them a question and experience it by yourself? Well, in this Tech Minute, you will meet the Vice President of Search and AI at Microsoft, Rangan Majumdar, as he shares a behind-the-scenes look at Microsoft's AI at Scale initiative, using huge pre-trained language models and how they're transforming our use of AI at Microsoft. Watch this one.
Hi, I'm Rangan Majumdar, Vice President of Search and AI at Microsoft. Today, I'm really excited to talk to you about AI at scale, which is how we use large pre-trained language models and how it's transforming our use of AI at Microsoft. Every story about AI at Microsoft starts with Bill Gates and Microsoft Research. When he started Microsoft Research, he had this vision that computers will one day see, hear, talk, and understand human beings. Over the last few years, Microsoft Research has had many breakthroughs, from vision in 2016, where we were the first company to reach human parity in object recognition, to speech a year later, where we reached human parity on one of the speech recognition challenges, then machine reading comprehension, where we were able to actually read and answer questions over documents, translation and speech synthesis, and then recently, last year, we were the first company to beat the general language understanding benchmark and got human parity on that. It was a really tough benchmark, which really needed us to understand language across 10 different tasks. So deep learning and Microsoft Research has been really, really powerful in terms of solving these extremely difficult challenges. It's great that we're making so much progress on these research benchmarks, but what really matters is taking this technology and bringing it to customers. So what we noticed was we had a lot of different AI groups across the company. So for example, in Microsoft Office, we had a team working on AI for better reading and writing assistance in Word. We had a team working on AI for better search relevance in Bing. We had a team working on AI for better document management in SharePoint. And then we also had a team in Outlook working on AI for better email management. We saw this as a big opportunity where we can actually have these teams collaborate, share, and actually build from each other, rather than just working on these AI algorithms independently. So to accelerate this change that we needed, we took advantage of three trends. The first trend is transfer learning, where you can train an AI algorithm on one set of data and set of tasks and actually reuse that same model across a different set of tasks. The second trend is around large pre-trained self-supervised networks. And what's happening here is you can actually train a very large neural network over massive amounts of data in a self-supervised way, where you don't actually have to give it supervised labels from a judge or a human. It can actually look at the data and then try to train itself. And with lots of data, and we can train really massive models. And these models are actually very, very powerful. And then the last trend was a cultural shift, where Satya says, as a company, we need to actually collaborate and share a lot more. And the results have been phenomenal. So if you think about where we were, let's say 3 years ago, the biggest model that Microsoft could train was about 10 million parameters. A year later, it was just 100 million parameters. And then earlier this year, we trained one of the largest natural language generation models at 17 billion parameters. And with each order of magnitude number of parameters, we see the model just get better and better. So Turing NLG is what we announced earlier this year. And just recently, OpenAI actually trained a model that's 175 billion parameters on the Azure infrastructure, similar to what we were able to do. So let me show you an example of what's possible with this Turing NLG model. The first is freeform generation. Here, I start and give it an example input, like how was the universe created? And this model actually just starts to generate the text that comes afterwards. So you can see, once I give it the prompt of how was the universe created, it starts talking about the Big Bang Theory and a lot of other scientific facts. Notice that it's grammatically correct, it's fluent. These are all the things that are ingrained in the model, including the knowledge that the Big Bang Theory is one of the most accepted theories around how the universe was created. And this is all stuff that's not just copying and pasting from the web. This is all knowledge that's ingrained in the Turing NLG model from just reading lots and lots of documents. For this AI transformation at Microsoft, we had to actually rethink the entire AI stack. From the very infrastructure, where we have to get the best AI accelerators. That includes NVIDIA GPUs, Intel FPGAs. the bandwidth. So we had to get a really high bandwidth network where we got NVLink and InfiniBand so that these GPUs can talk to each other super fast. And then software, where we actually innovated and built software called DeepSpeed, which allows us to train way bigger models much faster than if you didn't have it at all. And this is all on top of the same infrastructure, because what happens is these models are so big, they can't just fit on a single GPU. You actually need to spread the model out across lots of GPUs, and then the GPUs need to talk to each other. So DeepSpeed automatically does all that. And then we have Onyx Runtime, which can actually speed up both your training and your inference. So if you have this large model and you want to bring it to production, you can actually use Onyx Runtime for inference on the model. And then finally, we had one centralized team that would actually coordinate across all the research groups and product groups and build these really large pre-trained models. And that group was called the Turing Group, which now builds these Turing NLP models for the company. This allowed us to do a lot of custom capabilities through reuse. No longer did we have each of these teams working independently, but we would have one team build these really massive NLP models, the Turing Group, and then each of these groups would take that model and fine-tune them for their own scenarios. So the Bing team can use the model for their Bing scenarios, SharePoint can use it for the SharePoint scenarios, Word can use it for their Word scenarios, and so on. And this is what we mean by AI at scale for everyone. We had to build AI infrastructure at scale, which includes massive, the most powerful GPUs that can run over tons of data with really powerful networking. We build really large AI models at scale. So we're building models, billions of parameters that are super, super powerful. And then we need to deploy these AI models at scale. So we need to deploy them across hundreds of millions of customers. That means, they need to be robust. They need to actually run really, really fast. And they have to have low costs and high throughput. Now let me show you another example of what the Turing NLG model can do. Here I'm going to show you summarization. So what we've done is we've given a prompt of, this is the summary of Romeo and Juliet, and then the model takes that text and summarizes it in just a couple of sentences. Now I'm going to show you another example of summarization, where we take an article about, a Microsoft article about autonomous systems. Once again, we give it this really long piece of text, and then the model is able to summarize it in just a few sentences. Feel free to try summarization on your own. Let me show you some real examples that you can try out in Microsoft products. The first is Microsoft Bing, where we've created intelligent answers which summarize the web. Here you can ask a question like, how much is a blood test for dog allergies? And we read billions of documents in real time to find the best answer which summarizes what's out there on the web for you. Another example we have is semantic highlighting. So you can go and search for define RNN, and not only are we giving you documents which answer your question, but we're actually able to highlight the most important piece of text in that document. So for example, define RNN, we show a type of advanced artificial neural network that involves directed cycles in memory. This has been an awesome collaboration across multiple teams at Microsoft, which allowed for faster innovation. We hope it does the same for you as well. For the latest announcements, please look at the links below. We're excited to see what you build with the Turing language models and AI at scale. Thank you and goodbye.
Now let's hear from our